Hi everyone, I'm Angela Kreitenweis. I founded the Token Engineering Academy, and today I'll talk about managing complexity in token systems with large language models. Maybe for those who haven't heard about token engineering, some words about this new crypto-native discipline. It's the design, verification, and optimization of token-based economic systems, and as such, it is a new discipline in its own right, combining computer science, cryptography, game theory, economics. We draw from industrial and systems engineering, control theory, AI operations research, and we have the human layer with psychology, decision science, political science, governance, if you think of DAOs, and philosophy, law, and ethics. And this combination of disciplines is new, and TE Academy is the first organization to offer education in this sector. Complex systems, token systems are complex systems. They show many properties of complex systems, like in software complexity, of course. This is a diagram showing Aves contract interaction. So we have dependencies on the software level, and we have dependencies on the economic level. This is a typical diagram token engineers draw when mapping out a system design. So you see the arrows, the value flows, the cylinders, the pools, initial supply, reserves. You see the romp symbols. These show the policies and the mechanisms involved, and we also see some clouds, which are external systems we can't control and we don't model at this point. We have several layers that we want and have to observe and keep in mind in the design of token systems. We have dynamics over time, so these systems emerge and evolve over time. And we have interactions between mechanisms. And on top of that, we have activities of actors whose behavior we can't predict. And that's why token engineers run system verification and optimization, because we can't go with spreadsheet calculations. We have to simulate our system to observe the properties and to see if we get if we have flaws in the design, or if we get to edge cases or dangerous system states. And to observe these systems and to test them, to stress test them, we build models of our systems. And you can imagine no software, no simulation model can replicate the real world. So we have to take decisions on how to build a model to represent the world that we want to test and that we want to verify. And we have to understand and gain a good understanding if this model is capable to produce reliable and valuable insights. So this is decision-making when it comes to how should our model look like and how can we simulate the token system. Here's another example of a tool. This is Zenit Finance. It allows project teams to simulate the token distribution. And if you look at the left, you see some inputs, like a token price or a total supply, to then gain an understanding of supply and demand, of buying and selling dynamics. And if the token price and the supply are inputs, then we determine in such a simulation with what values, with what parameter settings we'd like to run. Meaning we don't predict price here. We go with assumptions about price and the right setting of supply to understand the dynamics of supply and demand under certain circumstances. So my message is, as a token engineer and generally, if we want to understand and design token systems well, we have to take decisions and we have to go with assumptions. And as in any other example of complex systems, we have to be very aware of our assumptions to then draw the right conclusions in order to then make the most of amazing tools we have at hand, AI and machine learning, to cluster and classify, detect patterns in transactions and behavior, to go with symbolic regressions to find mathematical relationships in data, to go with stress testing based on synthetic data, LLMs or VAE, or to use agent-based models and adaptive agents even to simulate our economy. So we have this interplay between human and machine reasoning. We, human designers, project teams, communities, take decisions on the purpose, on the goals of a certain design, and on the purpose of a token network. Then we use machine intelligence to understand, to run vast amounts of simulation runs, process vast amount of data, and apply smart methods to understand what could go wrong, if we are on the right track, how to secure an economy. And we draw conclusions from these insights in modeling and simulations, adapt the design, and then again, machines help us to understand the consequences of these design changes. It's like a conversation, which brings us to LLMs. Some months ago, we started asking, can we use LLMs to interact with models and simulations in a way that we can prompt LLMs to run simulations, and we not only expect an answer on a certain question, we can interact in order to change parameters and to let AI agents run analysis or even visualizations of the results. This is a project where I was collaborating with my colleague Rohan Mehta, and we called it CatCat-GPT. So the general idea is that we have a system model, what I was mentioning earlier, a moment ago. We build a model of our token system, and we have optimization techniques at hand. Machine learning, reinforcement learning. And on top of that, we use a layer of AI agents so that we can interact with the system model, run optimization techniques using human language. CatCat-GPT is the result, and it's a framework. It's available open source, and it's basically you can use it on top of any CatCat-RedCat model. CatCat and RedCat probably are the most powerful Python libraries for running token system simulations today. And we use the objects of CatCat models to access the model and then have three main components: memory, the core CatCat-GPT chatbot, and toolkits. Memory on top is information that LLMs off the shelf don't have access to. Information about our token system, information about a protocol. It can be documentation about the model at hand and data in tabled forms and also in vector databases. And the toolkit at the bottom are Python functions. We can access and execute Python functions through our chatbot. And this is the core piece of innovation in CatCat-GPT. So we have a chatbot that for the user has a user input in natural language and a user output in natural language. And at its core, there's a planner agent and an executor agent. And to be of any value for token engineers, these AI agents have to A, make sense of the human input, B, reason about the steps needed to get to a certain output, also reason about the memory and toolkits needed, plus decide on the sequence of steps. And here's where this deviates hugely and provides additional benefits compared to software as we know it today, because we don't predefine and determine the workflows. It's on the agents to decide how to combine memory and toolkits and how to run the steps to get to a certain result. And they run and execute based on contextual decisions in every single step. And it's amazing to see the capabilities of AI agent when it comes to taking a simple user input in a natural language and then go through all the steps needed to run a simulation and produce an output. Some more words. So at the top, We have long-term memory and short-term memory. Short-term memory is the history, the message history, what we have at hand based on an individual conversation. With the chat, we have new opportunities coming up with GPT-4o. And we have long-term memory, which is, for example, documentation of the model or other, think of the docs for any protocol to inform about a certain token system. We can store it or create embeddings and make it accessible and searchable for the AI agents in vector databases. And at the lower end, some examples for toolkits. We can run typical Python functions, statistical methods. We can access APIs to get data, on-chain data, off-chain data, and we can create dedicated agents as part of the toolkit. And the planner agent takes in the user input, reasons about the steps needed, about the tools and the context, creates a task list, and then hands over to the executor agent who is delivering results of sub-steps, step by step, again, applies reasoning about the steps needed, and then produces the output, including a documentation of the steps. And this is inspired by Baby AGI, AI-powered task completion, or React. Now, again, looking at this combination, we have the system model in the back, we have optimization techniques, and we have the layer of LLMs to make this accessible via natural language. It would not only be suitable for token engineers, basically it makes reasoning and decisions about a system design accessible to many more stakeholders. So we have, again, a perfect loop in human and machine reasoning, which could be applied to many more cases, not only cat-cat simulations. And this brought us to RetroPGF. RetroPGF is a funding paradigm and concept invented in the optimism community to fund public goods that are valuable to further develop the optimism ecosystem. And these public goods have been funded in 3 rounds so far. And if you look on the right, round 3 distributed 30 million optimism tokens to the ecosystem, to projects providing value to the optimism network. And by the time of decision making in round 3, this was worth 120 million USD. So this is a significant amount. And at the same time on the right, we have the number of projects also growing rapidly to 500 or 501 projects in RetroPGF round 3. And the decision making on what projects are actually valuable, and since RetroPGF is retroactive funding, evaluating the value they created for the optimism network, of course, this is a challenge. So we started exploring in February how AI co-pilots could help the decision makers in optimism RetroPGF to evaluate projects, to interact with data, the system model with applications in human language, to run data analysis, and even have access to much more complex simulations without writing code. And this is actually highly needed in DAO ecosystems, since on one hand, we want to have this diversity of projects, so it's hard to put them in boxes and evaluate with only 1 or 5 metrics. And on the other hand, equivalently, we want to have decision makers with a multitude of backgrounds. So how can we facilitate the evaluation in this case, and how can we build tools to have better insights and better data-driven objective decision making? And this brought us to building RetroPGF GPT. So again, what would be the equivalent of memory for RetroPGF GPT? Of course, data that is relevant in the context of optimism and RetroPGF. And this can be, for example, application data, data that projects submit. And again, more than 500 projects, their data their achievements. This is something that is hard to evaluate manually, right? Then here we have an example of the funding results in a public GitHub, so this is accessible publicly, or the impact equals profit. This is the key paradigm of how should we distribute funding to grow public goods in the optimism network. We define it as the grants received from projects should be equal to the positive impact they created for optimism, round by round by round. This sounds simple. It's actually hard to translate. Now, let's take a look at potential queries. So with LLMs, we can query applications. Like on the left, this is the user question, and on the right, you see the agent's output. So please list impact categories with the number of applicants and percentage of applicants funded. So batch holders and decision makers have access to prior rounds, to the number and the sizes of these rounds. We can query funding results. So, for example, provide the funding range per impact category. So we see the total applications, the average median received in funding, the percentage funded, etc. We can, as a decision maker, I can compare my voting to overall results to see my alignment with the overall community, project by project. Here we have a list of projects, how much optimism tokens they received, and my vote, and also the deviation. So there are many lenses we can explore the data available and the funding rounds in RetroPGF. Some more words on the toolkit. The equivalent of the toolkits in KakaGPT apply to RetroPGF. Some months ago, a discussion started, a very valid discussion started on how can we improve the evaluation of projects. And there has been some experiments, now also in round 4, that is starting in early June, to apply metrics-based evaluation. So in the past, it was up to the decision makers to define their own criteria, how to evaluate projects, and to come up with their own decision, how to allocate funding. And this is great when it comes to diversity and diverse perspectives. On the other hand, then it's hard to see if the community is aligned in the goals and in the ultimate purpose of RetroPGF. Okay, metrics-based evaluation could be one solution. Let's set up some metrics that seem to be useful for measuring the impact. Impact equals profit. And this is a screenshot of an early tool. And you can see on the right that there are some metrics like total transactions, projects, how frequently the smart contracts of a project have been utilized, or total transaction fees. So how many fees were created based on the project's contracts. And these numbers, of course, matter when it comes to how the value or the impact they created for the optimism network. Now, going further, we can look at, okay, if we have this toolkit and the community decided on metrics to apply how to evaluate projects, I can take a look and play with these metrics to see, for example, show me the alignment score. This is now a metric to show the difference between my vote versus the overall outcome. And I can even better understand metrics, asking can you explain me the alignment score? And this is often the challenge when people are looking at dashboards. How is this metric actually calculated? What does it say? What metrics or what values, what data does it use to, what data is processed, what's taken in, what's the inputs, and what's the output, to understand how this metric matters for my own decision. And LLMs can help us in understanding these metrics. Now, you might ask, okay, a voting single round is basically a calculation, and this is something that is not so super complex. However, if we look at this voting design, the logic, how RetroPGF distributes funds, This is actually relevant for the total optimism economy. Let's take a closer look. If we have RetroPGF, we distribute funds to valuable projects, and that way we grow developer activities and projects. Now remember, 30 millions distributed in round 3. This has an impact on secondary markets, right? Because it increases the optimism supply significantly. And not all projects might be able to just hold. Some might be forced to sell their optimism tokens to cover their costs. And so it has an effect on the price, and it has an effect on the fee revenues of the protocol, because it affects the price of transactions. Now, this could be a positive effect, because in USD value, this decreases the costs of every single transaction. This would be good. It definitely has an effect long-term on RetroPGF, because the fee revenues fuel the funds available for RetroPGF. And there's another effect of the developer activities and the projects on fee revenues. Because remember, the metrics shown beforehand, depending on the projects and what they build, they can, of course, affect the fee revenues via increasing block space demand, via the applications built on top of the protocol. And there's a final impact, if we look at secondary markets, to RetroPGF, because, of course, the dollar value of optimism tokens drives the funds available. If you look at the volatility of the token in the networks, of course it has an effect if the value decreases by 50% in how attractive is the funding RetroPGF for projects. So if we take a look at the system perspective, we see that only this this individual RetroPGF is not an isolated thing. It has an impact on the total optimism system. And via simulations, we can ask, how does RetroPGF impact the network growth of optimism or any other token system? How does RetroPGF impact the network value? And what are the best metrics to evaluate these evaluation criteria that should be also hard to gain? And how can we align incentives so that not only the projects, also the decision makers have skin in the game, as well as the optimism token holders overall? RetroPGF GPT is one way to make the systemic perspective more accessible to any stakeholder, to any decision makers in DAOs. It can help us to understand individual rounds, voting designs, the system perspective, how this affects the total optimism economy, and it helps us in taking objective and data-driven decisions. These are some of the requirements we've set up for RetroPGF GPT, like we want to make this equipped with an ever-growing set of tools and information. This makes total sense. If you think of the memory and the information that is ever-growing and is in evolution every single day about the optimism network and collective, the tools to measure impact, the tools to measure the effects of changes in RetroPGF on the total ecosystem. This has to be modular. Of course, it's also relevant how much we open source to grow the knowledge of the overall ecosystem. No open AI lock-in whenever possible. Let's see how alternative LLMs can cater the needs. A modular framework on the tool side, on the metric side with the DAO to take decisions on what are the most valuable metrics to observe, value add. And it also can inform how we collect data about projects, how this data is structured to make the most of the LLMs and have optimal quality in the results. And last but not least, this is also new areas for all decision makers because it's different to interact with LLMs in human language. It has many benefits, but we also have to understand the flaws. Overall, can LLMs support decision-making in DAO systems? Yes. Are they capable to become the interface between data, metrics, simulations, and human decision makers? Think of this loop. Absolutely, yes. Can we improve data-driven objective decision-making and optimization? Yes. And work is needed for sure when it comes to the memories, the information available, the function calling, the metrics, and the improvements and further development of this planning execution. This is the most important aspect, we want to have auditable and reproducible results and reliable results based on LLM interactions. That's it. And finally, we are running a study season at the Token Engineering Academy. You can find it at tokenengineering.net. If you're interested in complex systems and token systems, check it out. Thanks for today.